हेलो बच्चों, वेलकम टू विशन आईआईटी नीट एकेडमी। और आज हम लोग पढ़ने वाले हैं बहुत ही इंपॉर्टेंट चैप्टर। आज हम लोग कवर करेंगे जिसका नाम क्या है बच्चों? न्यूटन्स लॉ ऑफ मोशन। ठीक है, तो ये जो है बहुत इंपॉर्टेंट है आपका फिजिक्स के चैप्टर्स के अंदर। और हम लोग न्यूटन्स लॉ को डिटेल में देखेंगे। यहाँ पे हर एक सवाल को हम लोग करेंगे और कैसे सवाल को करते हैं इसको भी हम लोग यहाँ पे बहुत अच्छे तरीके से देखेंगे। ठीक है ना? सो हियर इज द न्यूटन्स लॉ ऑफ मोशन इन फ्रंट ऑफ यू, जहां पे हम लोग बहुत सारा या दे आर द डायग्राम्स गिवन। हम लोग साम करेंगे, इंक्लाइंड प्लेन का साम करेंगे, हम लोग पुलिस का साम करेंगे। सो ऑल दिस वी आर गोइंग टू सी इन न्यूटन्स लॉज ऑफ मोशन। सो दिस कम्स अंडर द सब्जेक्ट ऑफ फिजिक्स क्लास 11. Okay, so what are the topics mainly that we will cover in this? See, talking about the topics, हम लोग पहले इनर्शिया के बारे में देखेंगे कि इनर्शिया किसको बोलते हैं। देन हम लोग देखेंगे कि फर्स्ट लॉ ऑफ मोशन, न्यूटन्स फर्स्ट लॉ ऑफ मोशन क्या है ना? न्यूटन का कितना लॉज ऑफ मोशन है? न्यूटन हैज गिवन 3 लॉज ऑफ मोशन। तो तीनों हम लोग एक एक करके देखेंगे। फोर्सेस देखेंगे कि भाई फोर्सेस क्या होता है, व्हाट इज द एप्लीकेशन ऑफ फोर्सेस। इक्विलिब्रियम एंड फ्री बॉडी डायग्राम्स कैसे बनाते हैं, इसको भी हम लोग सीखेंगे। मोमेंटम को देखेंगे, मोमेंटम किसे कहा जाता है। देन कंजर्वेशन ऑफ मोमेंटम कब होता है हम लोग देखेंगे। इंपल्स क्या होता है, व्हाट इज कॉल्ड इंपल्स, वी विल सी। थर्ड लॉ ऑफ मोशन, देन द रॉकेट प्रॉब्लम्स, एटवुड्स मशीन, स्प्रिंग बैलेंस, कंस्ट्रेंट मोशंस, स्यूडो फोर्सेस, इन सभी का एप्लीकेशंस यहां पे हम लोग देखेंगे। ठीक है, देखिए अब तक तो हम लोग काइनेमेटिक्स में हम लोग देख चुके हैं ऑलरेडी कि कैसे मोशन किस तरीके से होता है, हाउ द मोशन एक्चुअली टेक्स प्लेस, है ना। दैट पार्ट वी हैव लर्नड इन आवर काइनेमेटिक्स। यहां पे इन न्यूटन्स लॉ हम लोग मेनली जिस चीज को देखेंगे वो है कि रीजन ऑफ मोशन। अगर भाई मोशन हो रहा है, इफ द मोशन इज टेकिंग प्लेस, है ना, तो व्हाई इज द मोशन टेकिंग प्लेस। कोई भी एक ऑब्जेक्ट वो रेस्ट पे है, तो रेस्ट पे है तो भाई रेस्ट पे क्यों है, क्यों एक ऑब्जेक्ट रेस्ट पे है। अगर रेस्ट में भी उस ऑब्जेक्ट के ऊपर क्या फोर्स लग सकता है, अगर फोर्स लग सकता है तो वो ऑब्जेक्ट रेस्ट पे क्यों है ना। सो दीज आर द क्वेश्चंस व्हिच वी विल ट्राई टू actually learn in this chapter. So mechanics, you see the mechanics can be divided into 2 parts. Like हम लोग इसको 2 पार्ट में डिवाइड कर सकते हैं। इसको क्या, पहला पार्ट को क्या बोलते हैं, स्टैटिक्स बोलते हैं, और एक पार्ट को हम लोग डायनामिक्स बोलते हैं। सो स्टैटिक्स का मतलब क्या है? देखिए स्टैटिक्स का मतलब है कि कोई भी एक ऑब्जेक्ट अगर स्टेशनरी है, राइट, एनी ऑब्जेक्ट व्हेन इट इज स्टेशनरी, स्टेशनरी का मतलब रेस्ट पे है। तो रेस्ट पे है इसका मतलब ये नहीं हुआ कि वो ऑब्जेक्ट उस ऑब्जेक्ट के ऊपर कोई भी फोर्स नहीं एक्ट कर रहा है, ऐसा नहीं है। रेस्ट पे है लेकिन उसके ऊपर फोर्स एक्ट कर सकता है, फिर भी एक्ट कर सकता है। जैसे कि मान लीजिए कि ये जो बोर्ड है ना, मैं इस बोर्ड को पुश कर रहा हूं। ओके, आई एम पुशिंग दिस बोर्ड, आई एम पुशिंग दिस बोर्ड। तो क्या हो गया, व्हेन आई एम पुशिंग दिस बोर्ड, है ना, ये बोर्ड क्या है, रेस्ट पे है, लेकिन फिर भी मैं तो फोर्स एक्ट कर रहा हूं ना इसके ऊपर। तो स्टैटिक्स मींस द स्टडी ऑफ फोर्सेस एंड देयर इफेक्ट ऑन ऑब्जेक्ट्स एट रेस्ट। इसको हम लोग क्या बोलते हैं, स्टैटिक्स बोलते हैं। और डायनामिक्स इज द स्टडी ऑफ फोर्सेस एंड देयर इफेक्ट ऑन ऑब्जेक्ट्स इन मोशन। जब ऑब्जेक्ट मेरा क्या है, मोशन में है, तो फोर्सेस का वहां पे क्या एप्लीकेशन होता है, इसको जब हम लोग स्टडी करेंगे या फिर स्टडी करते हैं, उसे हम लोग क्या बोलते हैं, डायनामिक्स बोलते हैं, राइट। अगेन द डायनामिक्स कैन बी डिवाइडेड इनटू 2. One is called the kinematics that deals with geometry of motion, another is called the kinetics deals with causes of motion. तो यहाँ पे Newton's law is all about basically kinetics. In Newton's law we will be talking mostly about the causes of motion. अगर मोशन हो रहा है तो why motion is taking place, क्यों हो रहा है मोशन। क्योंकि काइनेमेटिक्स हम लोग ऑलरेडी पढ़ चुके हैं, जहां पे हम लोग वेक्टर्स एंड जियोमेट्री ऑफ द मोशन के बारे में काफी बात ऑलरेडी कर चुके हैं। ठीक है, अब देखिए एक चीज को हम लोग समझते हैं कि अगर मैं आपको बोलूं एक चीज, क्या कि इफ आई से दैट यू प्लीज टेक ए ball. You take a ball, okay? You take a ball and you have taken the ball. Now I am saying that please roll this ball. इस बॉल के ऊपर आप क्या कीजिए, आप इस बॉल के ऊपर फोर्स अप्लाई कीजिए, है ना, एक फोर्स अप्लाई कीजिए इस बॉल के ऊपर. ये बॉल सपोज ग्राउंड पे है, ये ग्राउंड पे है, ग्राउंड हो गया मेरा. सो दिस इज अ ग्राउंड एंड यू हैव अप्लाइड सम फोर्स. तो इनिशियली ये बॉल क्या करेगा, ये बॉल रोटेट करेगा, रोटेट करते 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 आगे चला जाएगा. आगे जाते जाते व्हाट यू विल सी, यू विल सी दैट द बॉल विल कम इनिशियली टू रेस्ट. बॉल अपने आप ही रेस्ट पे आ जाएगा, है ना. तो इसी को जैसे कि आप देखते हो, ऐसे ही एरिस्टोटल साहब ने भी यही देखा, जो हम लोग डे टू डे देखते हैं कि एक फोर्स हमने अप्लाई किया, फिर किसी भी एक ऑब्जेक्ट को अगर हम लोग एक फोर्स अप्लाई किया उस पे, तो वो ऑब्जेक्ट मूव करता है. थोड़ी देर पे वो ऑब्जेक्ट किया जाता है, अपने आप रुक जाता है ना. थोड़ी देर मूव करने के बाद वो ऑब्जेक्ट अपने आप रुक जाती है. तो यही जो आप लोगों का जो ऑब्जर्वेशन है, मेरा जो ऑब्जर्वेशन है, वही एरिस्टोटल साहब का भी ऑब्जर्वेशन था. और उसने क्या कहा था, उन्होंने बोला था कि ओके, व्हेन वी अप्लाई अ फोर्स ऑन एन ऑब्जेक्ट, ओके, एंड it is like one time application, the force is not applied continuously, then the natural state of that object is it will come to rest. Okay, so the object will ultimately come to rest. But you see, ये तो हो रहा है in real life, okay, this is happening. But in real life, if I tell you that why this is happening, because you have applied a force of F, okay, and the ball rolled after some for some period of time, and then the ball came to its rest position by itself. Now it is at rest, okay, the ball came to its rest position by itself. लेकिन ऐसा नहीं होना था. ऐसा रियल लाइफ में क्यों हो रहा है? ऐसा रियल लाइफ में इसलिए हो रहा है because there are some other forces also which is acting against the force you have applied. आपने जिस दिशा पे फोर्स अप्लाई किए हो ना, उसके ऑपोजिट दिशा पे कोई और फोर्स एक्ट कर रहा है कंटिन्यूअसली, एंड दैट फोर्स इज बेसिकली ब्रिंगिंग दिस बॉल एट रेस्ट. ओके, एंड दैट फोर्स विच इज एक्टिंग कंटिन्यूअसली अगेंस्ट द मोशन ऑफ दिस बॉल, हम लोग उसको क्या बोलते हैं? फ्रिक्शनल फोर्स बोलते हैं. ओके, दैट इज कॉल्ड फ्रिक्शन. हम लोग उसको फ्रिक्शन बोलेंगे. सो द बॉल इज कमिंग टू रेस्ट बिकॉज ऑफ फ्रिक्शन हियर, बट एट दैट टाइम ऑब्वियसली फ्रिक्शन वाज नॉट समथिंग विच वाज डिस्कवर्ड. डिस्कवरी नहीं हुआ था उसका, फ्रिक्शन का. सो एरिस्टोटल सेड दैट if you apply force and leave it like that, then the object will eventually come to rest. Okay, that is why it is called Aristotle fallacy, क्योंकि fallacy का मतलब है he was wrong there, है ना. But see, in physics nothing is wrong, something like that. So maybe one of the observation, but वही से हम लोग तो सीखेंगे ना. With the mistakes only we learn. Okay, so now we will talk about what is called inertia. Inertia का मतलब क्या है? देखिए, inertia का मतलब like in real life situation, if I try to give you example, inertia means that when a body is at any state मतलब क्या है? The body can be in motion or the body can be stationary. कोई भी state हो उस body का, that state the body or that object will not like to change. Say for example, वो हम लोग के साथ भी होता है, right? Say for example, आप you are sleeping for it's a Sunday and you sleep for long hours in the morning. Now when your mother comes and asks you कि बेटा उठ जा, आप क्या एक बार में उठ जाते हो? You are in the relaxed mode. नहीं तो आज तो हम सोएंगे, ठीक है. So ये क्या है? Your mother is asking you to get up, but you are like not willing to change the state. You are in the sleeping mode and you are not willing to change the state. From the sleeping mode you are not willing to go to the active mode. तो ये तो मेरे साथ तो बहुत होता है. I don't know what about you. Okay, so this is called the inertia. Okay, ये तो एक एग्जाम्पल के माफिक मैं बोला, बट inertia का मतलब ये है कि a body, suppose a body is at rest. Suppose this is the ball. Now this ball is at rest. Okay, this ball is at rest position. So until and unless I am applying some external force, ठीक है ना, until and unless I am applying some external force to change the state of this ball. मतलब कि ये जो रेस्ट पे है ये खुद पे खुद मोशन में नहीं जा सकते हैं. Until and unless we are applying some external force. हमें एक एक्सटर्नल फोर्स चाहिए, हमें एक एक्सटर्नल फोर्स देना पड़ेगा, बाहर से फोर्स लगाना पड़ेगा, यू नो, टू कीप दिस बॉल रोलिंग. दैट इज, सो दिस इज द इनर्शिया ऑफ दिस बॉल. ओके, सो अब देख सकते हो, इफ ए बॉडी इज एट रेस्ट और मूविंग एट ए कांस्टेंट वेलोसिटी, ओके, इन अ स्ट्रेट लाइन, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. तो दो हो सकता है, दो तरीके का inertias यहां पे हम लोग डिस्कस करेंगे. एक तो हो गया inertia of rest. Inertia of rest का मतलब क्या है? When the body is at rest. तो कोई भी बॉडी जब वो रेस्ट पे है वो अपने आप उसका पोजीशन चेंज नहीं करेगा, स्टेट ऑफ पोजीशन चेंज नहीं करेगा, वो रेस्ट पे ही रहेगा. It is going to be at rest itself, just like that. And कोई भी बॉडी अगर वो मोशन में है, like when this ball is rolling, when this ball is rolling like this, okay, so when this ball is rolling, this ball will not come to rest by itself, it will keep on rolling. ये मूव करता जाएगा कांस्टेंट वेलोसिटी पे. कैसे? कांस्टेंट वेलोसिटी, v is going to be constant. देयर इज नो एक्सीलरेशन, एक्सीलरेशन नहीं रहेगा, कांस्टेंट वेलोसिटी पे ये बॉडी जाता रहेगा. और कैसे? स्ट्रेट लाइन पे. इट विल कीप ऑन मूविंग इन स्ट्रेट लाइन एट कांस्टेंट वेलोसिटी until and unless some external force is acted upon on this body to bring it out of this state. जैसे कि suppose this block I have taken. So when I take this block, you see this is the block. So when I am taking it, ये block क्या अपने आप मूव करेगा? कर सकता है क्या अपने आप मूव? जब तक मैं इसको मूव ना कराऊं तो सी, लाइक जस्ट सी, आई एम गिविंग सम फोर्स, मैं फोर्स लेकिन दे रहा हूं इस पे, बट स्टिल इट इज नॉट मूविंग. आई एम गिविंग सम मोर फोर्स, स्टिल इट इज नॉट मूविंग. Now I have given some extra force and see it has started to move. Now it is moving. Can you see that? So there is a particular amount of force जो मेरे को देना पड़ रहा है, उसके बाद ही movement is going to come to this body. So ऐसा भी नहीं है कि तुरंत फोर्स लगाने पे एक बॉडी मूव करेगा, ऐसा नहीं है. So there is some amount of force which you have to give. And if you give that amount of force, then only the body is going to move. Otherwise it will not move. है ना? So you see, इसको हम लोग क्या बोलते हैं? इसको हम लोग inertia बोलते हैं. अब inertia of rest क्या है? Inertia of rest है, कोई भी एक बॉडी अगर वो रेस्ट पे है तो वो रेस्ट पे ही रहना चाहेगा. कोई भी बॉडी हो गया वो रेस्ट पे है, वो रेस्ट पे ही रहना चाहेगी. So that is called the inertia of rest. Okay, a body at rest will remain at rest until and unless some amount of external force is applied on that body. Okay, that is called inertia of rest. And inertia of motion किसको बोलते हैं हम लोग? Inertia of motion is a body in motion will remain in motion in a straight line with constant velocity. तो यहां पे आप लोगों को बहुत चीजें मैंने यहां पे बोल दिया. फर्स्ट इज अ बॉडी इन मोशन, ओके, विल रिमेन इन मोशन इन अ स्ट्रेट लाइन, कांस्टेंट वेलोसिटी, until and unless it is acted upon by some external force some amount of external force to change that state. ठीक है, तो वो हो गया हमारा inertia of motion. और एक आता है आपका inertia of direction. inertia of direction क्या है? देखिए कोई भी एक बॉडी है, कोई भी एक बॉडी है मान लेते हैं, so there is any body, okay. Now if that body is moving in straight line, if that body is moving in straight line, this is the body, okay, this is the body. Now if it moves in straight line path, in order to change its path, if I need to change its path, I have to apply some force, otherwise its path is not going to change. ये straight line path पे ही move करेगा, okay. path को change कराने के लिए मेरे को क्या करना है? path को change कराने के लिए मेरे को force apply करना है उसके ऊपर, okay. So see who gave the law of inertia? The law of inertia was basically given by Galileo and law was formalized by Newton. Newton साहब ने क्या किए थे? Newton साहब ने he gave the law in a more formalized manner. ठीक है, physics के लिए Newton gave it. So see, Galileo had a very interesting experiment. What Galileo did was that he took a plank. Plank तो हम लोग समझते हो ना आप लोग? Plank means this, something like this, okay. I'll explain here. So okay, so this is, you see, what is it? He rolled a ball from here. He rolled a ball like this. यहां से, जब यहां से उन्होंने क्या किया, एक बॉल को रोल किया, so it was at this height h above the ground. You can say it is at height h above the ground. Ground के ऊपर कितना height है इस बॉल का? h height है. So it is from a height and he is rolling it. Okay. Now when both the ends of the planks are inclined equally, when both the ends of the planks are inclined equally, equally जब inclined है, तो ये देखा गया है कि this ball is going to be always, ये बॉल जो है ये उतना ही हाइट पे जाएगा, जितना हाइट पे ये बॉल था उतना ही हाइट पे ये बॉल को जाना है. So this ball went up to the same height h. So these are the same levels, okay. So same height. But when I am decreasing the elevation, okay, what he afterwards did was that he decreased the elevation. He decreased the elevation even more. He decreased the elevation even more. And then ultimately what he did was that he made it fully flat. And what was his observation? He made, and another thing which you should remember is the surface was very, very smooth. So it was very smooth surface. Okay. So the surface was very smooth. So friction हम लोग यहाँ पे क्या मान सकते हैं? जीरो मान सकते हैं. तो देखिए फ्रिक्शन तो जीरो नहीं होता, बट यस फ्रिक्शन को हम लोग जीरो मान के चलेंगे यहाँ पे, ठीक है ना. और फ्रिक्शन को आप नियर अबाउट जीरो बना सकते हो, ओके, थ्रू ट्रीटमेंट्स. तो गैलीलियो ने वही किया था. तो फ्रिक्शन, इट वाज अ वेरी वेरी स्मूथ सरफेस एंड फ्रिक्शन वाज टेकन एज जीरो. So what he saw was that कि when it is in the same inclination, it will move up to the same height. But when he is like decreasing the inclination more and more, the more he is decreasing the inclination, the ball is going to roll back farther. The ball is rolling back farther. The ball is even rolling back farther here. ठीक है ना? यहाँ पे ball is up to here. And finally, when the inclination is like 0 degree, then the ball is going to go up to infinity. The ball is, if there is no friction, then the ball will roll till infinity. Okay. So this is how basically inertia was discovered, you can say. Through this experiment, inertia was discovered. So what it means is that the ball is having the inertia of motion, and when there is no opposing force, when there is no opposing force, when the theta is 0 and it is absolutely flat, then हम लोग क्या बोल सकते हैं, there is no opposing force. एंड जब कोई भी opposing force नहीं है, the ball is going to roll till infinity. चलता चला जाएगा, चलता चला जाएगा, है ना. So this was the inertia. Okay. अब inertia के बारे में कुछ और बातें हैं जो कि मैं यहां पे बोलना चाहता हूं आप लोगों को. See, some of the examples of inertia that we day to day examples we should remember is that, say for example, inertia का मतलब क्या है. Inertia means, like I told you, a body at rest will remain at rest. So that is the inertia is what? It is the inability of a body to change its state by itself. So you can write inertia is inertia, it means it is nothing but the inability of the body to change its state, to change its state of motion by itself. This is nothing but inertia. मतलब कि एक बॉडी अगर वो मोशन पे है तो वो मोशन पे ही रहना चाहेगी, और वो अगर वो रेस्ट पे है वो रेस्ट पे ही रहना चाहेगी, ठीक है ना, जब तक ना कोई एक्सटर्नल फोर्स उस पे एक्ट कर रहा हो. राइट. सी, अ लॉट ऑफ इंपॉर्टेंट कंसेप्ट्स वी आर गिविंग इन यूट्यूब, ठीक है ना. सो all why we are giving so much important concepts and making you write all these things, all we want is nothing but your success in the examination. So please a lot of mehnat goes for it. So please students, this is earnest request to you, subscribe to the channel and keep reading. So see, this is inertia. Now here I can take some of the examples. What are the examples of inertia? Say for example, you are standing in a bus या फिर you are sitting in a bus. तो अगर आप एक मूविंग बस, सॉरी एक बस है जो कि पहले सपोज इट वाज एट रेस्ट. सो बस एट रेस्ट, इनिशियली एट रेस्ट, and you are inside the bus. And how are you? You are just sitting. So this is the chair. This is the chair and this is, okay, pardon my just drawing. And this is you, okay. तो ये जो है आप हो और मैं हूं, छोड़िए, ठीक है ना. तो you are sitting on the chair, right? You are sitting on the chair. Now what happens is that, you see what is going to happen if the chair is like this just, and you are here, this is you, okay. Now you are sitting on the chair like this and the bus suddenly moves. The bus suddenly moves. Now when the bus starts to move, बस जब शुरू कर देती है चलना तो क्या होता है. अब देखिए, आपका जो पोर्शन है, बॉडी का जो पोर्शन आपका चेयर के साथ लगा हुआ है, that portion of your body which is attached to the, or which is in touch with the chair, then that portion will instantaneously move. If the bus is moving with a velocity v, then your lower body is also moving with a velocity v. But you see, you were at rest now when the bus was not moving, it was just stationary. At that time आप कैसे थे? You were at rest, all the portion of your body were at rest. अचानक जब बस चलती है, just now from now onwards you need to observe these things. अचानक जब बस चलती है तो आप किस दिशा पे, like you tilt, in which direction? You will always tilt in the backward direction. You will always tilt because you see your lower portion which is in contact with the chair of the bus, it has started moving. But due to inertia, your upper portion of your body, it will resist the movement. it will still try to be at rest, and that is why you lean backwards. So this is an example of what kind of inertia? This is an example of inertia of rest. Okay, this is an example of inertia of rest. Similarly, another example we can give, which is inertia of inertia of motion. Like say for example, when you are standing, या फिर sitting भी बोल सकते हैं या standing बोल सकते हैं, in the moving bus only. Let us take the example of the bus only. You are standing like this and the bus is moving. Then you are in connected, like your leg is connected with the floor of the bus. Okay. So from the leg, obviously the motion is coming to the entire of your body. So you are also moving. Along with the bus, you are also moving. Now suddenly when the bus stops, it applies brake. What happens? Try to understand what happens. You were standing like this. आप ऐसे खड़े थे, like these are the legs. Okay. So you were standing like this. And this is the floor. This is the floor of the bus. Suddenly now you were moving. So you, in all the parts of your body, it was moving with velocity v, because the bus itself was moving. Velocity v. Okay. Suddenly when the bus stops, then what happens? V is equal to 0 हो जाता है suddenly. Then the first part of your body which is going to stop is going to be your legs, because the legs are in direct contact with the floor. So first your legs becomes the velocity of this part portion of your body v is equal to 0. ठीक है, ये अचानक क्या हो गया? Stop हो गए. So the lower portion of your body instantaneously comes to rest, but the upper part of your body, due to inertia, it will resist that. It will resist that change in the state of motion. It will not like to come to rest immediately. Then what is going to happen? Your head and your upper part of the body, okay, it is still having a velocity v. So you will lean in the forward direction. Lean in forward direction. So this is exactly what happens, okay, when the bus stops suddenly. आप क्या करते हो? आप ऐसे करके आगे जाके आप मुड़ जाते हो आगे के तरफ. So this is what happens, and these are the examples of inertia. Right. So there is a question. So let us see what it is talking about. When an object is at rest, okay, when an object is at rest, force is required to keep it in the rest state. No force is acting on it. A large number of forces may be acting on it which balance each other, or it is in vacuum. Okay. So what it is talking about, बोल रहा है कि कोई भी ऑब्जेक्ट वो जब रेस्ट पे है तो उस टाइम पे क्या कंडीशंस होते हैं? फोर्स इज रिक्वायर्ड टू कीप इट इन द स्टेट ऑफ रेस्ट. ऐसा तो कुछ नहीं है. एन ऑब्जेक्ट एट रेस्ट विल रिमेन एट रेस्ट. ओके, एन ऑब्जेक्ट एट रेस्ट विल रिमेन एट रेस्ट बिकॉज ऑफ इनर्शिया. ओके, सो नो फोर्स इज रिक्वायर्ड टू कीप इट एट रेस्ट. ऐसा नहीं हो खुद प खुद रेस्ट पे ही रहेगी. ओके, नो फोर्स इज एक्टिंग ऑन इट, ऐसा भी हम लोग नहीं बोल सकते. देखिए, अगर मैंने बोला कि एक ब्लॉक है, आई हैव गिवन यू अ ब्लॉक, ओके, and this block is at rest. I am applying a force of suppose 10 Newton from this side. Similarly, I am also applying a force of 10 Newton from this side. Okay, क्योंकि I am applying the same force from both the side, the block will be at rest only. वो तो मूव नहीं करेगा ना, क्योंकि सेम फोर्स मैं अप्लाई कर रहा हूं दो ऑपोजिट साइड से. So the block is still at rest. You can also say that, okay, another force which is mg, okay, we acting downward. So but we do not see the block moving down because there is some other force जिसको हम लोग बोलेंगे, हम देखेंगे इसको normal force which is acting on this block, है ना? So that is why the block is at rest. So no force is acting on it is also not an option. A large number of forces may be acting on it which balance each other. This is true. A large number of, इस एग्जाम्पल को ही आप ले लीजिए, बहुत सारा फोर्स एक्ट कर रहा है इस पे, है ना. 10 न्यूटन फ्रॉम दिस साइड, 10 न्यूटन फ्रॉम दिस साइड, mg normal, and the block is at rest. The block is still at rest. So a large number of forces may be acting on it which balance each other. Okay, so this 10 newton, this 10 newton balancing each other, normal and mg balancing each other. Okay. Okay. Now, if a force of constant magnitude acts in direction perpendicular to the motion of a particle, then what happens? What is being asked is, suppose there is a particle. Now the particle is moving like this. The particle is moving like this. Okay, with a constant velocity. आप बोल सकते हो v. Okay. Particle is moving with a constant velocity v. Now a force is acting on this particle perpendicular to the motion of this particle. Particle का motion इस direction पे है. The force is acting in this direction. Then what is going to happen? What is going to happen if the force is in perpendicular direction to the motion of the particle? ऐसा केस कहां पे होता है, आप लोग थोड़ा सोच के बताएंगे. We have discussed this kind of situation in our previous classes. This is the case of circular motion. If you see, the force is acting perpendicular to the motion of the particle. What such kind of force does? Such kind of force will change the direction of the motion of the particle. ऐसे करके particle का motion का जो direction है उसको change करवा देगा. It is going to change the direction at each and every moment. Okay? So speed is uniform. Yes, speed is uniform. Right? Momentum is uniform. हम लोग नहीं बोल सकते कि momentum is uniform. Momentum is not uniform here, क्योंकि you see the velocity is what? Velocity is having two parts. One is the magnitude as well as the direction. यहाँ पे magnitude change नहीं हो रहा है because of the force, but direction तो change हो रहा है ना. So as there is a change in the direction of the velocity, so that means the momentum is not uniform. So speed is uniform. Yes, speed is uniform. हम इतना बोल सकते हैं speed is uniform because speed is nothing but the magnitude. Okay. Okay. Now यहाँ पे क्या बोला गया है? A particle is found to be at rest when seen from a frame S1 and moving with a constant velocity when seen from another frame S2. Mark out the possible options. ठीक है, हम लोग ये possible options mark out करने बोले हैं, हम लोग करेंगे भी. But before that, I like to discuss with you before I move to that question. I would like to discuss with you Newton's first law. Okay? Okay. So, see, like we talked about inertia. हम लोग inertia के बारे में already बात कर चुके हैं. We talked about inertia. Now, Newton's first law, what it is saying? It is saying that Newton's first law says, very simple, a body at rest will remain at rest and a body in motion will remain in motion until and unless it is acted upon by an external force to change it. You can please write and I'll explain each and every words. A body at rest will remain at rest and a body in motion will remain in motion until it is acted upon by some external force. ओके, सो व्हाट इट मीन्स इज दैट कि कोई भी अगर बॉडी अगर वो रेस्ट पे है वो रेस्ट पे ही रहना चाहेगी, और अगर वो मोशन पे है इन अ स्ट्रेट लाइन वो मोशन पे ही रहेगी until and unless it is acted upon by some external force, until and unless we are acting some external force on that body. तो इसीलिए देखिए कोई भी एक बॉडी है उसका जो स्टेट है, स्टेट का मतलब है आइदर इट इज इन द रेस्ट और इट इज इन द मोशन. ओके, तो वो बॉडी क्या चाहती है कि उसका वो ही स्टेट मेंटेन्ड रहे, इसे ही हम लोग इनर्शिया बोले थे. सो दैट इज वाई न्यूटन्स फर्स्ट लॉ is also called the law of inertia. So you can write Newton's first law is also called the law of inertia. Introduces the inertial frame of reference as it is not valid in non-inertial frame. इसका क्या मतलब हुआ भाई? Inertial frame of reference and non-inertial frame of reference. See, frame of reference is what? From where you observe things to happen. Okay? सो फ्रेम ऑफ रेफरेंस हम लोग मान के चलते हैं. से फॉर एग्जाम्पल यू आर सीइंग अ कार एंड द कार इज इन मोशन, द कार इज जस्ट गोइंग लाइक दिस. नाउ यू आर सीइंग द कार फ्रॉम आउटसाइड एंड सपोज द कार इज मूविंग विथ अ कांस्टेंट वेलोसिटी v. तो आपको क्या लगेगा कि यस द कार इज मूविंग. ये हो गया आपका फ्रेम ऑफ रेफरेंस. ओके, एंड सपोज यू आर नॉट मूविंग, यू आर जस्ट स्टेशनरी. सो आपके ऊपर देन कोई एक्सीलरेशन नहीं है, देयर इज नो एक्सीलरेशन, राइट? नो नेट एक्सीलरेशन इज एक्टिंग ऑन यू. You are not moving with any speed, or like you are not moving also, you are just stationary and you are seeing a car passing by. तो आप हो गए inertial frame. When a frame of reference, always remember, when a frame of reference is in constant motion, constant velocity, if a frame of reference is at constant velocity or if it is at rest, then ये दो चीज हो सकता है. If the v is equal to 0, frame of reference जहां से आप देख रहे हो, if the v is equal to 0, that means it is at rest. If the frame of reference is at rest, then it is inertial frame. Or if the acceleration is 0, that means the frame is moving, but it is moving with a constant velocity. So acceleration is equal to 0. That is also inertial frame. But whenever acceleration comes in the frame, there the frame changes. It does not become, it is no more inertial. We call such frame non-inertial. Say for example, ऐसा भी तो हो सकता है ना कि there is a car which is moving with, there is a car which is moving with a constant velocity. Suppose constant velocity नहीं, with a constant acceleration a, and you are sitting inside this car only, and you are seeing a trees, trees, branches, everything outside. So you are basically sitting now in a non-inertial frame because this frame is moving with an acceleration. Okay, so that is what is meant by inertial frame and non-inertial frame. अभी हम लोग आते हैं क्वेश्चंस पे. Right, a particle is found to be at rest when seen from a frame S1 and moving with a constant velocity when seen from another frame S2. Mark out the possible options. देखिए मैंने पहले ही बोला था कि inertial frame में क्या होता है, either in that frame it is either it is the frame is at rest or the frame may be moving with a constant velocity. तो यहाँ पे वही बोला गया है कि a particle is found to be at rest when seen from a frame S1 and moving with a constant velocity when seen from another frame S2. Mark out the possible options. Both the frames are inertial here. ओके राइट। तो वी हैव डिस्कस्ड न्यूटन्स फर्स्ट लॉ। यहां पे वी आर गोइंग टू नाउ डिस्कस अबाउट मोमेंटम। नाउ व्हाट इज मोमेंटम? If I talk about momentum, then we need to understand that what is momentum. Momentum is nothing but it is the amount of motion contained in a body, I can say. Mathematically, momentum को हम लोग P बोल के डिनोट करते हैं, P, and P is equal to mv. Momentum is a vector quantity, okay? We write the momentum as P, and P is equal to mv, where V is what? V is nothing but V is the velocity. Okay? V is the velocity. And m is what? M is the mass of the body. M is the mass of the body. Right? So, it is the amount of motion. What I said, it is the amount of motion contained. So, if suppose I am saying that there is a ball and this ball is moving with a velocity v and this ball has a mass m, you can very easily find out the momentum of this ball. What is going to be the momentum of this ball? The momentum of this ball, you will say, the momentum of this ball is nothing but m into v. Okay? So see, m is a scalar quantity, your mass, and v is the vector quantity. So momentum becomes a vector quantity, like that. M times v, that is the momentum. Now, if the, so velocity means it is a vector quantity. So it is having basically two parts. दो पार्ट रहेगा ना वेलोसिटी के पास. एक तो रहेगा उसका खुद का मैग्नीट्यूड और एक क्या रहेगा उसका डायरेक्शन. So if the direction of a moving body changes, then also we will say that the momentum has changed. हम लोग बोल सकते हैं ना, if the direction changes, then also we will say that the momentum has changed. So okay, let us see. We have talked about momentum. हम लोग देख चुके हैं ऑलरेडी कि मोमेंटम क्या है. अभी हम लोग डिस्कस करेंगे फाइंड मोमेंटम ऑफ सिस्टम्स इन ईच केस. यहां पे जितना भी केसेस दिया गया है ना, आपको मोमेंटम ऑफ दिस सिस्टम निकालना है. तो देखिए ये क्या है, एक बॉल है, राइट? दिस अ बॉल और ए पार्टिकल विच इज मूविंग विथ ए कांस्टेंट वेलोसिटी v, and it is moving in this direction. You can say that you can take this to be the positive x side, है ना, and take this to be the positive y side. So it is moving along the positive x direction. So what is going to be the momentum? The momentum is going to be simple, m into v. Okay, m multiplied by v, that is the momentum. And if you take the direction, you have to make the vector, velocity vector. So this is also m into v and this is also m into v, but here the momentum, in this case the momentum is along this direction. It is along this direction because the velocity is along this direction, है ना. Similarly here be the velocity is along this direction, which is positive x direction. So the momentum will also be in the positive x direction, but here the velocity in the positive y direction, so the momentum is in the positive y direction, but magnitude सभी का सेम ही है, m into v. Okay, now we will talk about change in momentum. देखिए, through this example या फिर through this sum we are going to talk about change in momentum. Find change in momentum. In first case, ball dropped dead on striking. Ball dropped dead on striking का मतलब क्या है भाई? मतलब ये है कि मान लीजिए ये आपका जो है एक वॉल है, दिस इज अ वॉल, है ना. नाउ वी हैव अ बॉल लाइक दिस, we have a ball like this, and this ball is coming with a velocity v, striking it with a velocity v. Okay, this ball has mass m, striking with a velocity v. Now just after striking, strike होने के बाद क्या है, this ball is coming to rest. So I can say that initial momentum p बोलते हैं हम लोग, pi. What was the initial momentum pi? Pi was m into v. And what is the final momentum pf? Pf is nothing but the ball has come to rest, na? So it is m into 0. 0 means 0, m into 0, because the velocity is 0. So your delta p becomes pf minus pi. Final minus initial. So what is your final? Your final is 0. What is your initial? Your initial is mv. So your del p becomes, that is change in momentum, becomes minus mv. Okay, the minus sign is showing you the direction. Okay, change in momentum, ये जो है initial momentum का direction है, लेकिन change in momentum का direction क्या है? It is in this direction. Okay, opposite to the initial momentum direction. If you are finding the change in momentum, then the direction is in the negative x-axis. Got it? Now ball rebound with same speed. The ball is rebounding now. Rebound का मतलब क्या है? Rebound का मतलब यह है कि the ball is striking with a velocity v and again it is coming back with the same velocity v after striking. Like ऐसे करके मैंने कुछ फेंका, उसने मतलब after striking the wall it is again coming back with the same velocity. That is called rebound, है ना? So अभी देखते हैं if the ball is rebound तब क्या होगा. So this case is like the first case. Okay, and this is the second case when the ball is rebounding. So at that time हम लोग का क्या था? P initial क्या था? P initial was m into v. This is the positive x-axis, so I am taking this direction as the positive. Then this direction is going to be negative. Pf is how much? Pf is how much? Pf is minus m into v. बोल सकते हैं. तो डेल्टा p हम लोग क्या बोल सकते हैं? डेल्टा p को हम लोग बोल सकते हैं कि pf minus pi. Okay, so pf minus pi means pf is minus mv and pi is mv. So this is also going to be minus mv. So you see ultimately you are getting minus 2 mv. Okay, so with the negative sign. So when the ball is rebounding, एक चीज यहां पे आप लोग देखिए, when the ball is coming dead, dead means it is striking and coming immediately it is becoming stationary. It is striking and immediately it is stationary. Then what we are saying that the change in momentum is minus mv. And when the ball is basically coming back with the same speed, then the change is minus 2 mv. The change is minus 2 mv in the second case. Okay. Which have more change in momentum, rubber ball or iron of same mass? I want you to think about it. रबर बॉल में मोमेंटम चेंज ज्यादा होगा या फिर आयरन में, आयरन बॉल में? सपोज देयर इज अ वॉल, दिस इज द वॉल, सपोज, ओके, दिस इज द वॉल. नाउ I am striking it with a rubber ball. If this ball is rubber, case 1, rubber ले लेते हैं, rubber ball. Okay? So what is going to happen? Try and understand. Rubber ball, when you strike a rubber ball, same mass, m. So mass is going to be constant, okay, for both iron ball and rubber ball. Suppose 1 kg. Now 1 kg rubber ball, if you strike on a wall, what is going to happen? It is going to rebound. So if you strike it with v velocity, it is going to come back with v velocity. So this is called rebound. Okay. Then what is the change in momentum? In case of rubber ball, if I calculate the change in momentum, delta P, I can write that delta P is nothing but PF minus PI. So my PF is minus 2, sorry, my PF is basically minus MV and my PI is minus MV. Why? This is the positive direction, this is the negative direction. So overall minus 2 MV delta P. So this is coming to be the change in momentum in case of rubber. And change in momentum in case of iron, how much? Same wall. Now this ball is basically my iron ball, suppose. Suppose this is the iron ball striking with velocity v. This is iron. Okay. Now iron ball, when it is strike the wall, you do not expect the iron ball to come back with the same velocity or even come back. So what is going to happen with the iron ball? The iron ball will strike the wall and it will come immediately to rest. It will strike the wall and it will come rest. Okay. So my final velocity is 0. So my delta P iron, it becomes 0 minus mv. So that is equal to minus mv. So कहां पे आपका जो है मोमेंटम चेंज ज्यादा हुआ, आयरन बॉल पे या रबर पे? रबर बॉल पे. Obviously you will say that in the rubber ball the change in momentum is more, right? In the rubber ball the change in momentum is more. Okay. Okay. Now let us continue. See, a stone is dropped from a height of h. Okay. You please read it. A stone is dropped from a height of h. It hits the ground with a certain momentum p. Momentum means mv they are talking about. Certain momentum p. If the same stone is dropped from a height of 100% more than the previous height, the momentum when it hits the ground will change by. So यहां पे क्या पूछा गया है? पूछा गया है कि मोमेंटम चेंज कितना होगा. चेंज इन मोमेंटम हमें कैलकुलेट करना है. ओके, सो गिव इट अ ट्राई. वी आर गोइंग टू डिस्कस एनीवे. देखिए बोला क्या गया है, देखिए See, a stone is dropped from a height of h. पहले हम लोग ले लेते हैं कोई भी एक height. The height is h. Suppose this is the height. Okay? नहीं, थोड़ा सा छोटा करते हैं इसको. ओके, ऐसा है. तो पहले क्या बोला गया है कि अ स्टोन इज ड्रॉप्ड. दिस इज हाइट h. This is height h. Okay. Now a stone is dropped from here. It is dropped. Okay. So what is going to be when it drops? यहां पे जब ड्रॉप होगा तो इसका कितना वेलोसिटी रहेगा? v is equal to u plus gt, या फिर यू कैन से v स्क्वायर is equal to u square plus 2gh. 2gh, yes, that is better because we do not know the time. We'll use this equation. v is equal to root over 2gh. Okay, height से अगर कोई fall होता है, so this is the equation that is going to be we are going to take. So your v1 is going to be root over 2gh. Okay, this is done. Now when we are basically in the second case, they are saying that if the same stone is dropped with a height 100% more than the previous height. What does it mean? 100% more means 2 times. Okay, so the previous height was h. Now the v2, in case 2 they are saying the v2 is 2h. So the v2 is going to be root over 2g into 2h, and which is nothing but 4gh, root over 4gh. Okay, this is going to be root over 4gh. Now what is the momentum here? What can be the momentum here? P1. P1 is mv1, mass is the same, so m into v1. So I can write here it is nothing but m root over 2gh. और यहां पे हम लोग क्या बोल सकते हैं? यहां पे हम लोग क्या बोल सकते हैं? P2 को हम लोग बोल सकते हैं कि P2 is nothing but m into v2, and which is nothing but m root over 4gh. Okay, exactly this we can say. So now delta P is nothing but P2 minus P1. Okay, and percentage change अगर हमें find करना है, then P2 minus P1 by P1 into 100. This is going to give you the percentage change. So P2, see, m into root over 4gh minus root over 2gh. Okay, so you can say that this is going to be so P2 I can write like so if you do this, so because you just what we are doing is we are finding the change, है ना? So if you calculate 1.414 minus 1 into 100, so what is this 1.414? Root 2 is 1.414 na? Minus 1, that means 0.414 into 100. So 0.414 into 100 is 41.4%. So the change is going to be 41.4%. This is going to be the change. Okay, so 41%. Okay, अभी हम लोग चलते हैं कंजर्वेशन ऑफ मोमेंटम पे. आफ्टर द कंजर्वेशन ऑफ मोमेंटम we will basically, okay, first and foremost let us say talk about conservation of momentum. So when is momentum conserved? We need to understand that. When is momentum conserved? When no external force is acting on a system, then the momentum of that system is going to be conserved. जब कोई भी external force I am talking about, वो सिस्टम के अंदर इंटरनल फोर्स हो सकता है, लेकिन हम लोग देखेंगे बाद में अगर कोई एक्सटर्नल फोर्स एक्ट नहीं कर रहा है उस सिस्टम के ऊपर, देन द ओवरऑल द मोमेंटम ऑफ दैट सिस्टम इज गोइंग टू बी कंजर्व्ड. ओके, लेट अस टेक एन एग्जांपल. सपोज आई टेल यू दैट okay, there is a solid stone like this, a rock. Now this rock is basically moving with a speed of v. This rock is moving with a speed of v. Then you have to understand that each and every particle on this rock, it is basically moving with the same speed v, है ना? So this is also moving with a speed v, this is also moving with a speed v, this is also moving with a speed v, this is also moving with a speed v. All the particles are moving with the same speed v. Okay, now if the overall mass of this rock, पूरा सब कुछ मिला के, is m, capital M, and what is this capital M? You can say that this is the overall mass of the rock, and the capital M is nothing but it is the summation of all the small particles, है ना? जितना भी स्मॉलर पार्टिकल्स है वो सब का अगर मैं सम करूं तो मुझे ओवरऑल क्या मिलेगा? द एंटायर मास ऑफ द रॉक. सो दिस इज गोइंग टू बी नथिंग बट द समेशन ऑफ द स्मॉलर पार्ट्स फ्रॉम I is equal to 1 to I is equal to n, and this is the total mass of the rock that I can say. So I can say from conservation of momentum that if the rock overall is moving with a velocity v, then what is the total momentum of the rock? The total momentum of the rock is nothing but m into v. बोल सकते हैं ना? The total momentum of the rock is nothing but m into v, and that is equal to what? It is equal to, it is equal to m1 into v plus m2 into v. सभी सब particles are moving with the velocity v only. So m3 into v plus m4 into v plus dot dot dot. बोल सकते हैं? That means summation of m I equal to 1 to I equal to n into v. बोल सकते हैं? इसको बोल सकते हैं हम लोग. So the total momentum, this is going to be give you the total momentum of the system. Okay, now conservation of momentum we will see in more detail. ओवरऑल इतना समझ में आया? मुझे लगता है कि आप लोगों को समझ में आ गया मैं क्या बोलना चाहता हूं. ओके, लेट अस फर्स्ट टॉक अबाउट न्यूटन सेकेंड लॉ and then we will talk about conservation of momentum. See what Newton's second law is saying here. Newton's second law says that the rate of change of momentum, is directly proportional to the force applied. Try and understand what I mean to say by that. Newton's second law states that force is nothing but it is the rate of change of momentum. मतलब मोमेंटम एक बॉडी का चेंज हो रहा है और किस रेट पे हो रहा है वो इंपॉर्टेंट है. हाउ फास्ट और हाउ स्लो द मोमेंटम ऑफ दैट बॉडी और ए सिस्टम इज चेंजिंग, दैट इज डिटरमाइंड बाय द फोर्स, एक्सटर्नल फोर्स दैट आई एम अप्लाइंग. व्हाट डज इट मीन? इट मीन्स दैट if no external force is applied then there is no change in momentum. हम लोग बोल सकते हैं ना, because what second law is saying, the external force on a body is proportional to the rate of change of its momentum. Means अगर external force apply हो रहा है कोई भी एक particle के ऊपर, then that particle में क्या आएगी? that particle में change in momentum आएगी, है ना? तब हम लोग क्या मेजर करने वाले हैं कि ये जो चेंज आया है इस चेंज का रेट कितना, कैसा है, व्हाट इज द रेट ऑफ चेंज. ओके, देन वी विल मेजर द रेट ऑफ चेंज. लेकिन अगर आप मान के चलिए कि मैंने कोई एक्सटर्नल फोर्स अप्लाई ही नहीं किया तो क्या होगा? दैट मीन्स द पार्टिकल, जो पार्टिकल है उसका मोमेंटम चेंज नहीं होगा. सो दैट मीन्स वी आर अगेन गेटिंग बैक टू आवर फर्स्ट लॉ दैट अ बॉडी इन मोशन विल रिमेन इन मोशन. मोमेंटम चेंज नहीं हुआ का मतलब क्या है? उसका वेलोसिटी कांस्टेंट है. इट विल कीप ऑन मूविंग इन द सेम वेलोसिटी. सो सी हाउ फर्स्ट लॉ एंड सेकेंड लॉ दे आर जस्ट इंटरकनेक्टेड, राइट? सो दिस इज फिजिक्स, ओके, वेयर यू विल फाइंड इंटरकनेक्शंस एवरीवेयर. सो दैट इज व्हाई वी आर पुटिंग सो मच एफर्ट टू मेक योर फंडामेंटल स्ट्रॉन्ग. सो सी एक्सटर्नल फोर्स ऑन ए बॉडी, सो आई कैन से दैट force is directly proportional to, हम लोग बोल सकते हैं force is directly proportional to dp dt. बोल सकते हैं ना, where this is nothing but the rate of change of momentum. Okay, this is exactly what Newton's second law is saying. So F I can write is equal to K into dp dt. Can I write this? From here I can write what is the del P, dp dt. So you forget about this. What is momentum? mv. So from here I can write that force is equal to, you take K, m into Vf minus Vi by delta t. Can I write this? क्योंकि देखिए ये जो डेल पी है या फिर डीपी है, ये क्या है? चेंज इन मोमेंटम, एंड चेंज इन मोमेंटम इज व्हाट? m into final, m into v final minus m into v initial. This is the change in momentum. mv final is pf, mv initial is pi. So del p is nothing but pf minus pi. So exactly that we have written. So यहां से हम लोग बोल सकते हैं, we can write from here that force is equal to K into m into, now you see what is this? dv dt. This is dv dt. Okay, this is dv dt. So rate of change of velocity with time, I can say this to be acceleration, right? Now here we take it in such a way that the k value comes to be 1. कैसे हम लोग करते हैं इसको? So for this k value proportionality constant to be 1, you take, we define the force 1 Newton force. हम लोग ऐसे करके define करते हैं 1 Newton force को, कि 1 Newton force is that force which when applied on a mass of 1 kg, it makes that mass accelerate by 1 meter per second square. I am again repeating, 1 Newton force is that force which when applied on a mass of 1 kg, it makes that mass of 1 kg accelerate by 1 meter per second square. ठीक है? That we call 1. So k value is coming 1. So ultimately I can say that force is equal to mass into acceleration. Okay? So force is equal to mass into acceleration. This we can say. But here, yes, ये तो बोलते हैं हम लोग, बोल रहे हैं, and this is how I have also derived. You can see the how we have derived it. But the thing is, this is not Newton's second law. Always remember, sometimes there is a miscommunication, or we think Newton's second law to be like, if you ask what is Newton's second law, people will directly say F is equal to ma. Now this is Newton's second law doesn't say that. Newton's second law doesn't say that F is equal to ma. So this is a derivation that we are doing, and ultimately, yes, we are getting into it. Okay, force is equal to mass into acceleration. That's a different question altogether. But Newton's second law is saying that the external force applied is directly proportional to the rate of change of momentum. So that means if a body is changing its momentum at a faster rate, then more force is applied on that body. And that if that body is basically changing its momentum at a slower rate, comparatively less force is applied on that body. That's it. That much is Newton's second law. Another thing is, in case of variable mass, I will not be able to use this expression, because if the mass varies, obviously in most of the situations our masses will be fixed, constant. Then if you apply F is equal to ma, this is all right. But you see, if the mass varies, then where the problem comes. Say for example, when the mass varies, let us understand this. So that is why, see, like what I said that F, you can say, is equal to K into dp dt, right? So I can say that this is nothing but d ये बोल सकता हूं ना मैं, I can say this. So that means it is nothing but dm dt into v plus v, so okay, dm dt into v plus m into dv dt. This we can write. Okay. So if we can write this, now you can see m into dv dt is nothing but mass into acceleration. But this v into dm dt, okay, if the mass is constant, then this dm dt terms become 0. If the mass is constant, but if the mass is also changing with time, then you cannot say that this dm dt term is 0. You need to understand this. If the mass is also changing with time, then you cannot say that, simply you cannot say that force is equal to m into a. Then if you are saying force is equal to m into a, you are just considering this term, you are ignoring this term, and this term is not 0. When this term is not 0, in case of rockets, I tell you an example. Rocket के साथ क्या होता है ना, as the rocket moves from the earth towards upper portion, a lot of weight actually reduces with time. The weight of the rocket reduces with time. Why? Because see, a lot of exhaust gases are already, fuel is already exhaust. The rockets also drops its shells. तो ये जो shells rocket ने drop कर रहा है, तो उन shells का भी तो एक weight है अपना ना. So it loses its weight with time. And in the application, in this, if you apply in case of rockets that F is equal to ma, then you see a big term actually you are ignoring. Okay, so we cannot ignore that term always. But yes, simplicity, ठीक है. In most of the cases in Newton's law, we will see that F is equal to ma. That is all right. Right. Now here you see a cricket. So okay, let us solve this and then I'll go to some other questions also which we skipped. Okay, a cricketer catches a ball of mass कितना 150 gram in 0.1 second, moving with a speed of 20 meter per second. Then cricketer experiences a force of. Okay, so I want you to read this once. Okay, let us see. A cricketer catches a ball of mass 150 gram. So what is the mass? It is 150 gram. That means 0.15 kg. Okay. Okay. And what was the initial speed? The initial speed was u is basically 20 meter per second. The final speed is basically 0 because it has, the cricketer has caught it. Okay. And what is the time? Time is basically how much? 0.1 second. So this is the time. Okay. Now we need to calculate the force experience. So force is what? Rate of change of momentum. Force is equal to dp dt. We have seen that. So that means force is what? What is the momentum change? The momentum final is going to be 0. Momentum initial is going to be minus 20. Okay. And the time is 0.1. So if you put the value, what? This is 0.15 into, you can say 20 by 0.1. So this is going to give you how much? Like 0.15 I can say into 200. So this is 30 Newton. Okay. So a force of 30 Newton is going to act on the cricketer. So from here you try to understand one thing. Okay. So yes, this is the answer. Okay. But you understand one thing. in cricket you must have seen that what happens when the ball comes. When the ball comes, the wicket keeper, most if you have seen keeping. So wicket keeper, what he does is that he takes the ball and moves his hand in the backward direction like this. He'll never take the ball like this and stop instantly. Then what is he doing in this process? In this process, what he is doing is he is increasing the delta t times, delta t value. So you see the force is equal to, I can say, del P by del T. Now if the del T increases, the force will decrease. Okay, because del P is constant. Whatever speed, with whatever speed the ball is coming, that speed has to stop. So he will stop that ball. Okay, so he has to stop that ball. So the speed has to stop anyway. Okay, so the delta P is like constant. लेकिन यहां पे डेल्टा टी को हम लोग क्या कर सकते हैं, हम लोग चेंज कर सकते हैं हमारे अकॉर्डिंग. वी कैन चेंज द डेल्टा टी इफ वी आर इंक्रीजिंग द डेल्टा टी वैल्यू. ओके, बाय गिविंग इट मोर टाइम टू स्टॉप, द फोर्स विल अल्टीमेटली रिड्यूस. Okay, now let us see this. An explosion breaks a rock into 3 parts in a horizontal plane, right? 2 of them go off at right angles to each other. This is a very good and important sum, okay? Please try to understand. हम लोग देखेंगे इसको. Okay, क्या बोला गया है? An explosion. There is an explosion which has taken place. And an explosion breaks a rock into 3 parts. It has broken the rock into 3 parts. पहले वो एक ही पार्ट था, अब एक्सप्लोशन के बाद वो 3 पार्ट पे टूट चुका है. Okay, in a horizontal plane, the 2 of them go off at right angles to each other. The first part of mass 1 kg moves with a speed of 12 meter per second, and the second part of mass 2 kg moves with a speed of 8 meter per second. If the third part flies off with 4 meter per second speed, then its mass is. इसको पहले समझते हैं क्या बोला गया है, पहले तो उसको समझते हैं. देखिए, ये हम लोग करेंगे लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम से. क्यों हम लोग, देखिए कहां पे हम लोग लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम यूज करेंगे, ये सबसे इंपॉर्टेंट है जानना. Then you will get to know by yourself only when to use law of conservation of momentum. So they are saying that there is a particular rock like this. ठीक है, नो एक्सटर्नल फोर्स. कोई एक्सटर्नल फोर्स के बारे में कोई बातचीत हुआ है क्या अब तक क्वेश्चन में? कोई एक्सटर्नल फोर्स के बारे में बात नहीं हुआ है. सो दे आर नॉट टॉकिंग अबाउट एनी एक्सटर्नल फोर्स. व्हाट इट मीन्स, एक्सप्लोशन हुआ है, बट एक्सप्लोशन, यू ऑलवेज रिमेंबर, एक्सप्लोशन इज बिकॉज ऑफ इंटरनल फोर्सेस ओनली. एक्सटर्नली कोई, मतलब एक्सटर्नली ऐसा तो नहीं है ना कि कोई किसी ने घूसा मार दिया या फिर कुछ मार दिया एंड देन इट इज एक्सप्लोडिंग. नॉट लाइक दैट. ओके, सो इट इज द बिकॉज ऑफ द इंटरनल फोर्स it is exploding. Okay, so an explosion breaks a rock into 3 parts. Suppose this rock is broken into 3 parts. ये हो गया एक पार्ट, ये हो गया एक पार्ट, और ये एक पार्ट, ऐसे करके 3 पार्ट में डिवाइड हो गए. एक पार्ट ऐसा मूव कर गया, एक पार्ट ऐसा मूव कर गया, एक पार्ट ऐसा मूव कर गया. ठीक है, आइडियली दिस इज व्हाट इट मीन्स. ओके, सो लेट अस सी. नाउ बोला गया है कि द फर्स्ट पार्ट ऑफ मास 1 kg, सपोज दिस इज द फर्स्ट पार्ट. ओके, मास 1 kg, मास कितना है 1 kg. ओके, एंड इट इज मूव्स विथ ए स्पीड ऑफ 12 मीटर पर सेकेंड. 12 मीटर पर सेकेंड. ठीक है, तो आपका जो है ये जो मेरा फर्स्ट पार्ट है P1 का, मतलब फर्स्ट पार्ट का मैं अगर मोमेंटम कैलकुलेट करूं तो कितना आएगा, m into v, and this m into v is 12, right? So 12 kg meter per second. 12 kg meter per second. right? And the direction is going to be along this direction only. Always remember, this is going to be along this direction only, क्योंकि velocity इस direction पे था. Second part, the second part of mass 2 kg. और एक part है जिसका mass है 2 kg. तो इसको ऐसे ले लेते हैं. Suppose this is the second part. अब mass कितना है 2 kg. Moves with 8 meter. So the momentum P2 is going to be 2 into 8, right? So 16 kg meter per second. Okay. So you see, ये अगर मेरा P1 है और ये अगर मेरा P2 है, तो मेरा P1 और P2 का कोई तो रिजल्टेंट होगा. So what is the direction of the resultant? Now if you see, if you know vectors, if you attended our lectures on vectors, you know, you will instantaneously say that yes sir, ये मेरा P1 है, ये मेरा P2 है, and these two are at right angles 90 degree. So obviously we will have a resultant, and the resultant is along this direction. From the vector law of addition you can find it out. Parallelogram law. So this is my P resultant, I can say P resultant. अब जो P resultant होगा वो P resultant के opposite मेरा क्या होगा? P resultant will have some magnitude and some direction. Now I am asking you, what is going to be the magnitude of the third part? The third part का जितना momentum होगा वो exactly P resultant को balance करेगा. क्यों? Because you see, initially the rock was at rest before explosion. So before explosion, when the rock was at rest, its total momentum was 0. Total momentum of the system is 0. Now after explosion also, the total momentum of the system has to be 0, because there is no external force which has acted on the system. Okay, everything has happened because of internal force only. So we will basically apply law of conservation of momentum. So you forget about P resultant, you can directly say that my P3 is going to be along this direction. And what is going to be my P3? You see, यहाँ पे आपका P3 होगा, और you see the P resultant is going to be, अगर मैं P resultant का वैल्यू फाइंड आउट करूं, the P resultant is going to be how much? Root over 12 square plus 16 square. So it is root over 144 plus 256 root over, so it is 20 kg meter per second. This is P3. P3 is 20 kg meter per second. 20 kg meter per second. So this is P3. And what is P3? You can say P3 is nothing but mV3, m3 into V3. Okay, and what is V3? So P3 is 20 is nothing but m3 into 4. So यहाँ से m3 का मास आपको मिल रहा है 5 kg. Okay, read this sum. This is also very important. बहुत अच्छा sum है, आप एक बार पढ़ लीजिए एक दफा, फिर हम लोग देखेंगे. Okay, a machine gun fires a bullet of mass 65 gram with a velocity of 13,000 मीटर पर सेकेंड. ठीक है, मशीन गन है जो कि फायर कर रहा है क्या, किसको? एक बुलेट. सो इनसाइड द मशीन गन देयर इज अ बुलेट ऑफ मास 65 ग्राम. बुलेट का मास कितना है आपका? 65 ग्राम. विथ अ वेलोसिटी ऑफ, इट इज फायरिंग द बुलेट विथ अ वेलोसिटी ऑफ 1300 meter per second, the man holding it can exert a maximum force of 160 Newton on the gun. ओके, जिस आदमी ने गन को पकड़ा हुआ है वो मैक्सिमम 169 न्यूटन झेल सकता है. ओके, द नंबर ऑफ बुलेट्स ही कैन फायर पर सेकेंड विल बी. देखिए यहां पे भी हम लोग क्या देखेंगे ना, जब बुलेट और आपका गन, बुलेट गन सिस्टम, व्हेन इट कम्स, एवरीथिंग इज ड्यू टू इंटरनल फोर्सेस, नो एक्सटर्नल फोर्स इज अप्लाइड. क्योंकि गन और बुलेट दोनों मिला के आप एक सिस्टम मानते हो, समझ रहे, गन एंड बुलेट दोनों को मिला के हम लोग एक सिस्टम मान रहा है यहां पे. तो क्या होता है ना, जब हम लोग ट्रिगर दबाते हैं बुलेट का, सॉरी गन का, तो क्या होता है, देयर इज सम, बिकॉज ऑफ द इंटरनल मैकेनिज्म ओनली द बुलेट विल मूव, ओके, विथ इट विल गेन सम मोमेंटम. ओके, सो नो एक्सटर्नल फोर्स इज रिक्वायर्ड, एक्सटर्नली कोई फोर्स अप्लाई नहीं कर रहा है कोई किधर से भी. सो वी कैन अप्लाई कंजर्वेशन ऑफ मोमेंटम हियर, right? If no external force is there, we can apply conservation of momentum. So here you can directly say that we are applying conservation of momentum, and we can say that, okay, force is equal to, I know that it is nothing but dp dt, rate of change of momentum. हम लोग देखे हैं न्यूटन सेकेंड लॉ से. This we can say that this is nothing but, see, before firing, what was the momentum change for the bullet? What was the momentum rather? Sorry. Before firing, momentum kya tha? Before firing, it was 0. After firing, what is the momentum? mv, mass of the bullet into the velocity of the bullet. That is the momentum after firing. Yes. And if per second we are firing n number of bullets, then rate kya hai per second? If per second we are firing n number of bullets, n bullets per second, then the rate is going to be, rate of change of momentum is going to be n into m into v. So that I can write simple, F is equal to n into m into v, where m is the mass of the bullet, v is the velocity of the bullet, n is the number of bullets fired per second. So 169 is the maximum force that you can withstand. That is equal to n into what is the mass given, इसको हम लोग क्या बोल सकते हैं, 0.065 बोल सकते हैं ना, केजी में अगर मैं कर रहा हूं तो, into velocity 1300. Okay, so your n value is going to come from here. Your n value 169 divided by 0.065 into 1300, that is going to be your n value. Okay, let us calculate this. So it is 0.065 into 1300, 84.5. Okay, so you can say it is 169 divided by 84.5 is equal to n. 169, so it is 2. Okay, so your n value, you can say n is equal to 2. So we are ultimately firing, so यही पूछा गया है आपसे, the number of bullets he can fire per second will be 2. So 2 is the number of bullets he can fire per second. Okay, so let us move forward. Okay, we have seen this. Okay, this also you have seen. Okay, please read this question. We'll see this. Okay, let us see. It is saying a 0.5 kg ball moving with a speed of 12 meter per second strikes a hard wall at an angle of 30 degree with the wall. Okay, it is reflected with the same speed and at the same angle. If the ball is in contact with the wall for 0.25 second, the average force acting on the wall is. So what is the average force acting on the wall? Force is what? We know that force is nothing but rate of change of momentum. Let us see. Let us solve this. Okay. So suppose this is your wall. Okay, just a minute. So this is your wall. Okay. Now what they are saying, a 0.5 kg ball moving with a speed of 12 meter per second. So the ball is coming like this. Okay. Mass of the ball is 0.5 kg. This is the mass of the ball moving with a speed of 12 meter per second. So it is coming with a speed of 12 meter per second. This is 12 meter per second speed. Okay. It is reflected and okay, and the wall, it is basically strike and hard wall at an angle of 30 degree with the wall. So this angle is 30 degree. Always remember, this angle is 30 degree, they have said. Now after that the ball is again rebounding back. ऐसे करके स्ट्राइक होने के बाद बॉल क्या कर रहा है, ऐसे करके रिबाउंड बैक कर रहा है, जबकि ये एंगल फिर भी गिवन है, फिर से 30 डिग्री बना रहा है, दोनों गिवन है यहाँ पे. देखिए अब एक चीज देखिए आप लोग, प्लीज माइंड इट. सो इफ आई ड्रॉ ए नॉर्मल हियर लाइक दिस, and if I ask you what is the angle it is making with the normal and the wall, normal means normal is perpendicular to the wall. So this much is 30 degree means this angle is my 60 degree and this angle is my 60 degree. Okay. Now this was my mv. Okay, initially ये मेरा mv है. So initially this was my mv. This mv I can basically, this is the direction initially, na? So I can break it into two parts. One is mv cos theta, where what is this theta? This theta is basically this theta, 60 degree. So mv cos 60, mv sin 60. Okay, and finally also I can break it into two parts, mv cos 60, mv sin 60. Okay, so this is my momentum initial. इनिशियल मोमेंटम को मैं दो पार्ट पे तोड़ सकता हूं. वन इज mv cos 60 एंड अनदर इज mv sin 60. सो mv cos 60 इज इन दिस डायरेक्शन, पॉजिटिव x डायरेक्शन. इसको भी मैं दो पार्ट में तोड़ सकता हूं, mv cos 60 in the negative x direction and mv sin 60 in the negative y direction. If you now subtract the pf minus pi, ultimately you will see these two, mv sin 60 initial and mv sin 60 final, these two are basically, in both the cases they are adding up, they are getting added up and in the same direction they are added up, so they will be negative. See, they will cancel each other. Ultimately मेरा क्या होगा, along this axis my momentum, I will get the change in momentum. So if I say what is the change in momentum, you see it is m delta p, I can say is nothing but m into v into cos 60. Okay, this value, and it is 2 times. Why it is 2 times? Because 2 times it is getting added. So you will get it 2 into 0.5. 0.5 is nothing but half. What is the velocity? 12 and cos 60. Six. So del P we are getting as 6. Okay. So this is the del P value that you are getting. Now they asked you the force. The force is going to be delta P by T. So 6 by 0.25. Time is 0.25. So it is going to be 6 by 1/4. That means 6 into 4. 24 Newton. So the force value ultimately, it is how much is the force the ball is striking on the wall? It is 24 Newton. So you can see this is a AI PMT question.